Hello everybody, my name is González. I am co-founder of Aulasneo, an open edX service provider for companies and educational institutions. Today I will talk about machine learning applications for open edX. I will not go into the details of machine learning. There is a lot of documentation, tutorials, and courses on the web. I recommend looking for this topic in edX.org, where you will find lots of excellent courses to take. I will first make an introduction of basic machine learning concepts applied to e-learning use cases, and then I will show you how to create a simple system to recommend courses to users. When talking about machine learning, a first question that usually arises is about what we should expect from such an algorithm that we cannot do in another way. Which kind of questions can we ask to a learning machine? In a traditional analytics system, we take all the data sources like databases, log files, user input, etc. Then we process all the data by joining, filtering, aggregating, making calculations to derive the data we need. The result is always a deterministic and unique function of the inputs. In a way, all the new data is redundant. No matter how complex is the calculation, we will never find anything new. We are just reformatting the existing data to make it more understandable. If the source data is true, then the result will always be true. In science, this is usually called deduction. In machine learning, we talk about inference as a more general way of obtaining new information from existing data. We do not really care if the result is true or not. It may be even impossible to ever evaluate it. Instead, we'd rather ask if the result is valid, feasible, likely, or just acceptable. We can ask about events that may happen in the future, persons' preferences, or unpredictable conditions. Before trying to formulate a question, we should clarify about who this question is about. In e-learning projects, our main entities are students and courses. Enrollments are important entities. They are the relationship of students and courses. But there are other interesting objects of possible questions, like exams, course sections, videos, forum threads, certificates, enrollment tracks, etc. Machine learning is about creating a function called the model that will take an input and produce something, the inference. The input to the model is a set of values that define the object of the question. These values are called features. These features will have to be prepared before sending to the model. For example, the course start and end date may define part of a course. However, maybe that course duration has course ended. Days since the course has started are easily calculated from them and better input for what we want to solve. The model has a fixed internal structure. There are several model types like linear learner, matrix factorization, k-nearest neighbors, neural networks, to name a few. Each of them is suitable for a particular type of problem. However, given the type of algorithm, they always have a set of parameters that can be tweaked The process of finding the best parameters is what we call training or fitting the model. And we can do this by presenting a set of features and desired outputs to a training algorithm. There are three main types of machine learning problems: classification, regression, and clustering. Classification consists of assigning a label to an entity based on its feature. The case of course recommendation that we will show later is an example of binary classification. Is this course interesting for this user? Yes or no? A regression is a problem where the answer is in a continuous set, like a real number. Which price should this new course have to maximize sales? Is an interesting question. Clustering allows to group together objects that share a pattern in their features without predefined labels. For example, we could feed a machine learning model with forum posts to detect groups of interests and better create cohorts. So, to summarize, once we have an idea of what we need to know, we should first decide the type of output desired. If to label the object, find the magnitude for it, or find other similar objects. Second, state very clearly the question we want to ask. Third, choose the best algorithm that can answer this type of question. And fourth, select and prepare the features that will define the object, and that are relevant, of course, to the question. Now, from a pragmatic point of view, when you want to start using machine learning for your project, you have two options. Write an algorithm from scratch, or use an existing algorithm available in the market. Writing your own algorithm will allow you to make a tailor-made solution for your specific problem. However, be aware that you will need strong knowledge of mathematics and programming. Note also that this approach may consume a huge effort and yet bring poor results. Using an existing algorithm will be faster and easier to start solving common problems. Many algorithms are available for free and very well documented. You just must be sure that your problem is exactly what the algorithm solves. For this example, we have chosen the recommendation problem, which is very common in e-commerce and streaming services. Its objective is to offer a list of options that a user might be interested in, like products to purchase, songs to listen, or movies to watch. We will use it to create a system that suggests courses that a user might be interested in taking. You can use many libraries to implement the machine learning system, like TensorFlow, MXLearn, Scikit-learn. As a platform for this project, we use SageMaker, the AWS service for machine learning. It automates the whole process and has a huge library of algorithms ready to use out of the box, many of them for free. But of course, you can also do it in your own computer. The algorithm that we use is called implicit Bayesian personalized ranking, or simply implicit BPR. It is very well documented and shows to give much better results than other algorithms for this problem. It is called implicit because users do not vote up or down for courses. Instead, we take each enrollment as a positive preference, while all other courses where the user has not enrolled in are not necessarily negative preferences. They may just be courses that the user had never seen. It is Bayesian because it uses a statistical approach to train the model. It uses the Bayes theorem to maximize the probability of a set of parameters given the training input set. The object of the question is a set of pairs user course. The question is if this pair is likely to be an enrollment, in this case of user. In other words, if the user might be interested in enrolling in the course. We will train the model with all previous enrollments. So the features are very simple. Only the user ID and the course ID. Internally, the model uses a technique called matrix factorization. The factor matrices hold the parameters that are adjusted during the training process. The output will be an ordered list of course IDs for each user. Let me show you how it works. This is a Jupyter Notebook. Jupyter Notebook is a tool widely used by the data science community because it combines formatted text, code, data, and shell commands in an interactive document. I am running this document from my local computer, but you can also use a SageMaker notebook or run a Jupyter Hub Docker container, for example. Just don't run it in an edX production instance, because it may load the server too much. You can download this notebook from our GitHub repository. To get the algorithm, you will need to go to the SageMaker marketplace and subscribe to Outpace's implicit BPR at no cost. The first step to train the model is getting the enrollments data from the LMS. The only information that we need is the user ID and the course ID from the student course enrollment table in the edX app MySQL database. You can run this command in your LMS and copy the CSV file created to the local directory of the Jupyter Notebook. I will not run it here because I already have my file that looks like this. We use Pandas, a Python library that allows manipulation of large datasets. We have 22,360 enrollments in this sample dataset. However, many users are enrolled in only one or two courses. We are not interested in users with few enrollments because we need to learn from those who enrolled in other courses after taking one or two before. Therefore, we will filter out all users with less than 4 enrollments. Now we will take a sample of 100 enrollments to test. We will remove these enrollments from the training dataset to hide them to the learning algorithm. Later, we will ask the model what courses it would recommend to these test users and check if the courses they have enrolled in appear in the ranking. The training data file will be the original dataset removing users with very few enrollments and the data we will use for testing. We prepare it and upload it to the cloud. Now we are ready to create the model and train it. Okay, the training job took less than 5 minutes to complete. Now that the model is trained, we create the function that will answer our recommendation requests. It took less than 1 minute to be created. Okay, we are ready to start asking recommendations to our model. We can do one by one. But let's create a batch request for the users in the list of 100 enrollments that we have sampled before. From each of the unique users in the list, we will ask the model to give a top 10 ranking of courses that may be interesting to them. Note that in the sample of 100 enrollments, there may be users with more than one enrollment. That is why we may have less than 100 different users in the list. We upload the batch request to the cloud and start the transform job. This process took around 5 minutes to run. So here we have the output. Let's download it to the local directory and see what it looks like. Let's take one random user. These are these users' enrollments that we showed to the model. And this is the enrollment that we hid for testing. Now let's see the ranking that the model would recommend to the user. We can see that in many cases, the course that the user actually enrolled would have appeared in the top 10 ranking of recommendation, and in some cases, highly rated in the ranking. Let's repeat it with some other users. To measure the system performance, we have made several runs using the same dataset, but with different samples of 100 enrollments to check. We have found that in average, more than 38 times out of the 100 enrollments, the enrollment fell into the top 10 ranking that would have been shown to the user before enrolling in this course. Moreover, the shape of the histogram shows that the user real selection is more likely to be highly ranked. As a conclusion, we see that this implementation gives results that can be accepted to implement a marketing strategy to recommend new courses to enroll. I hope you have enjoyed this presentation. If you have any questions or comments, please feel free to contact me at andres@aulasneo.com. Thanks.